Okay, thank you. So I think because I was actually following Andreas, I thought I'll change the title of my presentation. First of all, Andreas, thanks for making the slides in English so that I could at least read and understand what you were saying, although I didn't understand a single word of what you said. But I think what I'm going to do is, in the next few minutes, essentially tell you why this trend is likely to be an extremely powerful trend, and what are some of the challenges in realizing what Andreas talked about in terms of how do you actually realize this? What are the technical challenges, and how do you actually overcome those challenges, including knowledge management, automation, and so on and so forth. So if you actually look at, I mean, while Andreas gave you sort of a business view of why CIO as a broker is actually an interesting concept, there is actually a technical view that you can arrive, that will lead you to exactly the same observation. And that is that if you really look at how technology is changing over the last several years, you basically see a sort of an exponential growth in terms of the capability of different technology platforms. And Moore's law is a great example of that. If you, on the other hand, look at the ability of an IT organization to actually exploit that technology, whether it is internal IT organization or a service provider, generally you find that that's sort of growing but not growing as fast. Right? So if you really look at the gap between these two curves is really what you can call the technology debt, or to put it differently, this area under this between these curves is really the lost opportunity for an enterprise. Right? Now, obviously, as these two curves diverge, basically the greater if you will, the loss of opportunity. And in fact, because of this reason, most organizations are unhappy about every contract that they sign, right? Because over time, it essentially becomes more and more outdated. In fact, what happens is that periodically, you actually do a renegotiation of the contract either internally or externally, and by doing that, essentially catch up with the technology, and then the same pattern repeats again. So the question now is, because of this, you are actually starting to go to a model that Andreas talked about as sort of this functional outtasking, where you actually try and divide, not do sort of one large, sort of one neck to choke model, but basically divide this up into a large number of smaller tasks that can be outsourced. But more interestingly, when you do that, and if you are able to do this at a fast pace, then you can actually keep catching up with the technologies much faster and thereby significantly reduce really the lost opportunity. And that is the real reason behind why this whole idea of functional outtasking and getting control to the CIO to actually assemble the best of breed services at any given point in time to achieve the best possible outcome is a really key driver for the future. Now, the question really that we have to ask ourselves is this really possible? Is this realizable? What are the challenges that one would need to actually overcome to do this? So there are three challenges that I wanted to talk about. The first one is really transparency. While it is easy to say that, I mean, you saw the sort of the inverted L model that Andreas talked about, that you can actually switch in, switch out services. The reality is that an enterprise has to determine which service it wants to actually switch in or switch out. What is the impact of that particular change? Why should you switch in, switch out these services? What is the business case for doing that? And all of this is actually very hard to answer. I mean, today, for most enterprises, the IT environment is extremely complex. It is highly siloed. And very few people have an end-to-end understanding of exactly what is going on. And because of that, it is extremely difficult to do any sort of change impact analysis. What is the impact of actually changing service from one provider to another, from an internal provider to potentially an outsourced provider. So that's the first problem. We basically lack transparency. We lack end-to-end understanding to be able to actually reason about the impact of change. The second problem is portability. The services today are not standardized in most enterprises. In fact, there is ad hoc customization or personalization that happens of these services. And because of that, there is heavy dependence on people and tacit knowledge. So it is easy to say that I want to switch from one provider to another provider, or from an internal organization to an external provider. It is very hard to do that, and do that quickly, because of the fact that there is a large amount of tacit knowledge that essentially people hold about how that service is actually getting rendered, right? In fact, because of this tacit knowledge and dependence, if anybody was trying to actually do a change in a service provider, whether it is from one internal group to another internal group, from an internal group to an outsourcing organization, or an incumbent outsourcer to a new outsourcer, you realize that the amount of time it takes to do transition is quite large, because that time is actually spent in doing knowledge transfer, in essentially ensuring that the tacit knowledge of the incumbent is indeed actually passed on to the incoming provider. In fact, if it takes 6 months for you to do transition, then obviously you will not be actually switching providers every year, because otherwise you'll be in perennial transition, right? You will never actually get to steady state. So this is a fundamental problem, right? I mean, our services today are not portable. The only portability you have seen to date is actually at a very low technology level, where you can actually go and acquire and move, let's say, a virtual machine from one public cloud to another public cloud, or from a private cloud to public cloud, and vice versa, right? It is actually very, very hard to do this at complex services. And that's, as I said, it's primarily based on the challenges, tacit knowledge. And then the third problem that I want to actually talk about is the problem of configurability. So when you look at almost any service, you looked at that chart that Andreas had, where he had large number of little boxes. Each box is providing a different service, an incident management service, or a service request management, or performance and capacity management, or access and entitlement management, or even compliance management. These things are heavily integrated with, each of these services are heavily dependent on and integrated with wide range of tools that are actually part of an enterprise, right? And if you actually change service or service provider, and you bring in a new set of tools, processes, all of your existing set of tools and services have to integrate with these new services that you have actually just onboarded. This configuration itself is a non-trivial task in most organizations, because today, in fact, most of these tools are manually configured. Each of these tools have their own interfaces, and it'll take you weeks, if not months, to actually just reconfigure your environment to accommodate a new set of tools or services. So once again, because of this, it takes a fairly large amount of time and effort to actually move from one service provider to another service provider, or to actually truly realize the potential of rapid functional outtasking, as we talked about earlier. So the question is, how do we actually overcome these challenges? What can we do in order to address this? And so the next 10 minutes or so, I'm at least going to give you some initial thoughts on how we believe this can be done, and how some of these ideas are actually getting implemented, let's say, in the context of Deutsche Bank and some other large organizations. So the first problem I talked about is transparency. How do you actually gain transparency in a large enterprise? And so the inspiration here is really to draw from this. I mean, the picture is of a compound eye of a dragonfly. A dragonfly's eye is actually very interesting, if you know about this. It has a large number of little lenses each lens is fixed and directional. And each lens is actually not very sophisticated. It's very simple. But the compound eye is actually quite sophisticated. It actually achieves 360-degree vision by combining all of these little signals that are coming from a large number of little lenses. So while each lens of a compound eye is nowhere close to the sophistication of our eye or our lens, the compound eye is actually more powerful than our eye. Right? Now, if you apply this analogy to enterprise IT, the world is very similar. If you look at enterprise and enterprise IT, we have a large number of little lenses that are actually available in your enterprise that are collecting vast amounts of information about an IT environment, IT estate, and so on and so forth. Each one of them in silo is good, but not great. I mean, it does not give you information that allows you to truly understand what your enterprise looks like. You really have to put them together and run sophisticated analytics in order to derive insights that actually give you the kind of transparency that we are talking about. Now, the question is this actually doable in the world of IT, and are there examples where this has been successfully done? So one good example of where these ideas of actually bringing data from large number of sources and analyzing them together has been successfully deployed are social network analytics, right? I mean, Ashok talked about this in the morning, of doing this inside an enterprise. If you really look at even Facebook and Facebook analytics, it's doing exactly the same, where in some sense, Facebook essentially models the world consisting of entities and relationships. Entities are people. Entities are high school, city that you live in, movies that you have watched, books that you have read. And relationships are, I have read this book, I have liked this book, I went to this school, I currently live in this city, and so on. So if you think about it, Facebook basically builds an extremely large, complex graph of large number of entities. And then they essentially mine that graph to identify interesting insights, actionable recommendations, and so on and so forth. That, oh, you are friends with this person, you have similar interests, you have read a book, so, or your friend has read a book, you may like it. Right? So that's exactly how they provide actionable recommendations. And so this is very much an example where, once again, data from large number of different sources are actually getting integrated, analyzed to build essentially a model of the system, which is then used to provide that kind of transparency and analysis. So the key solution and principle or idea is really integrate data from a variety of sources, because no single source of data is actually capable of giving you what you want. It will not give you the transparency that you need. Use that data to actually model the system and then drive a lot of analytics onto that data, onto the model to derive insights and actionable recommendations. So that's the first thing that is required in order to create that transparency. That is the foundation of this whole idea of CIO as a broker or next generation IT. The second question is portability, right? The second challenge. And if you really look at sort of the inspiration to be derived here is, I mean, you just look at how, for example, mobile service providers or telecom networks work. And you get complete portability, you get number portability. When I roam, I just landed from India. My cell phone works anywhere automatically. The data plans, the call plans get connected completely transparently. I know nothing about what is happening at the back end, right? Now, the question is, how do you actually achieve something similar in the world of enterprise IT? Now, once again, have we seen evidence of this? Absolutely. If you really look at virtualization, that is really the fundamental enabler that has allowed us to separate the what from the how, the service from the implementation, right? And virtualization has been applied at all levels of IT. I mean, there is user interface virtualization. Earlier we talked about things like HTML5 or essentially separating the content from the device view and essentially dynamically choosing that based on the device on which it is rendered. There is application virtualization. And of course, all the infrastructure virtualization that comes from all your software-defined networks, software-defined data centers, software-defined servers and storage, and so on and so forth. Now, when you apply this to services, though, the problem is a little bit harder, because you need to not only virtualize and make technology portable, but you also have to capture a lot of knowledge about how the service is actually getting rendered. And so this is where this concept of knowledge standardization becomes extremely important. How do you capture knowledge and in particular separate sort of the what are you doing in a service from how are you doing, and within how you want to actually separate what is general from what is situation specific. So basically, if you think about knowledge, you have sort of the factual knowledge, if you will, that is of general interest. It's factual about, let's say, an Oracle environment or an SAP environment or a Linux environment or a Hadoop cluster and so on. Whereas situational knowledge is about the specific set of applications that are using Hadoop cluster and are using Linux and so on within your environment, the workload pattern, the types of incidents and issues that are arising in that environment and so on, and any additional compliance and regulatory requirements that you may have, which are very specific to that particular instance of that technology. It is critical to be able to externalize a lot of this tacit knowledge in order to be able to then automate. If you cannot externalize this, then automation becomes very difficult to do. And if you are able to separate this what from how as well as the general from situation specific knowledge, then it becomes relatively easy to organize knowledge in reusable components and then build upon lower level knowledge to build more complex operations, to build even more complex operations and so on by chaining together knowledge, much like as Chris was talking about earlier, sort of combining these little atomic knowledge elements or knowledge items to actually construct a complex resolution process or a solution process. So this is actually key to enabling portability. If you are able to capture this knowledge and organize it in a reusable form, then it becomes relatively easy to actually transition from one provider to another or from one person to another person and not actually have a loss of knowledge. The third problem that we talked about is configurability, right? How do you ensure, and so the inspiration there is how, for example, manufacturing industry has really gone from craft, or if you will, manual engineering to mechanized, to what I would call automated and precision engineering systems. So in the case of mechanized, I mean, there was a certain amount of automation that was done, but if you had to take one assembly plant that is today building one product and actually now reconfigure that assembly plant to actually build a different product, a huge amount of effort is required to essentially go from one product or one product line to another product line. With precision engineering and automation, you essentially, in some sense, reprogram the machine to do the new product or the new product line and essentially dramatically shrink the amount of time required to build a new product or a different product than what you are building. So the question is, how do you do this? And are there evidence of doing something like this in IT? And absolutely. I mean, you look at 3D printers today, or you look at even compilers that we have built. You basically write a program in a high-level language, and you compile down to a different platform to execute. 3D printing is exactly the same. You basically specify a high-level, you create a high-level specification or a model of what you want to print, and then you are able to essentially configure the printer to actually print a 3D object on the fly. We need to do exactly the same for services, and that requires, once again, as I said, I mean, essentially each of these services today are built, I mean, first of all, services are hierarchical, so more complex services built on lower level services, which are in turn built on even simpler services and so on. And each of these services consume resources. They could be technology resources or people resources. They are managed using tools. And all of them have to essentially get configured appropriately in order for the end-to-end service to work. And so the solution principle that is extremely important is how do you, first of all, describe these services at a level where they capture all the knowledge required for its execution, and more importantly, how do you take that specification and then translate that down to all the tools and technologies such that that service can indeed be deployed in an automated manner. So to end, essentially what, if you really take a step back and look at what we have talked about, this whole idea of CIO as a broker, or more interestingly, making services configurable, portable, and transparent. By achieving this, what we are in effect trying to do is move the world of IT, which is today somewhere between craft and mechanized, and heavily dependent on people and tacit knowledge, into a world where it becomes a lot more precision engineering, where you can describe formally the service as well as essentially do change analysis, understand how to deploy and configure that service rapidly onto a new platform. And that is really the foundation for, if you will, industrialization of overall IT. With that, let me stop, and I'll be happy to take a few questions. Thank you.
Well, the actual question, I mean, to the whole concept is, where do we interface? I know we've discussed this before, but I think it's a discussion we should take more public. Is where do we interface with people who are skeptic about the question of standardization of knowledge, standardization of process, and all these things? So, where is a good starting point to actually move from the early adopters to a more generalized organizational approach?
Yeah, I think, I mean, we have discussed this before. It is a difficult question. My current feeling is that what we are finding is that it is a lot easier to start at the lower layers of IT stack today because there is a lot more reuse of knowledge across enterprises. It is also much easier to actually validate and check the knowledge at the lower levels of IT. And it makes it much easier to actually argue whether this particular solution will deliver what you are expecting, or what the benefits that people are expecting. Obviously, as you go to higher and higher levels of IT, it becomes obviously more and more complex, more and more non-deterministic, and it is actually more of a educational issue in terms of how do you actually increase comfort for an organization to actually absorb this level of automation or this level of knowledge externalization.
Further questions? I think everything is clear.
Okay, thank you very much.